The Cold War was an era defined by profound ideological conflict and an unyielding technological arms race. As the space race unfolded, charting new territories beyond Earth, nations pursued not only scientific achievement, but also a decisive strategic advantage. The vast expanse of orbital space represented the ultimate high ground, offering an unprecedented vantage point for observation and intelligence gathering. Within this clandestine struggle for supremacy, the United States Air Force initiated a highly secretive program, the Manned Orbiting Laboratory, or MOL. This was not simply a scientific endeavor. It was an ambitious project designed to place human operatives in space, providing a unique capability to monitor an adversary's movements, assess their capabilities, and maintain the delicate balance of power through superior intelligence. The very existence of MOL underscored a period when the imperative of national security drove innovation to its farthest limits, blurring the lines between peaceful exploration and military reconnaissance. The Manned Orbiting Laboratory program formally commenced in December 1963, representing the United States Air Force's determined effort to establish a dedicated military presence in Earth orbit. The core objective was to perform advanced reconnaissance and surveillance missions, leveraging human intellect and adaptability for tasks that automated systems were then considered unable to fully achieve. The MOL design envisioned a cylindrical laboratory module, approximately 10 feet in diameter and 41 feet long, equipped with an array of sophisticated optical and electronic sensors. Crew access to this orbiting laboratory would be provided by a modified Gemini capsule designated Gemini B, which would dock directly with the MOL module and serve as the crew's return vehicle. The entire assembly, comprising the Gemini B and the MOL laboratory, was to be launched atop a powerful Titan III-IC rocket from Cape Canaveral, a vehicle capable of placing substantial payloads into orbit. Astronaut pilots for the program were meticulously selected from within the ranks of military test pilots, ensuring a cadre with exceptional flight experience, a deep understanding of operational requirements, and a capacity for discretion. Over two separate selections in 1965 and 1966, a total of 17 individuals were chosen for this highly classified mission, undergoing rigorous security clearances. Their training regime was extensive, encompassing not only conventional astronautical skills, but also highly specialized instruction in reconnaissance techniques, sensor operation, intelligence analysis, and evasive procedures. These men were preparing to become orbiting observers, tasked with identifying and reporting on Soviet and Chinese military installations, missile sites, and naval movements with a level of detail and real-time assessment believed unattainable by robotic probes. The MOL program thus embodied a direct response to perceived Soviet advances in space-based intelligence, pushing the boundaries of manned spaceflight into the realm of overt military utility, all shrouded in the deepest secrecy. Throughout the mid to late 1960s, the Manned Orbiting Laboratory program progressed with significant momentum. Ground facilities were constructed at various sites, hardware development contracts were awarded, and a single unmanned test flight, designated OPS-0055, successfully demonstrated the structural integrity of the Gemini B capsule and the Titan III-IC launch vehicle in November 1966. This initial success bolstered confidence in the program's technical feasibility and the capabilities of its prime contractor, the Douglas Aircraft Company. However, as the decade drew to a close, a confluence of factors began to fundamentally erode the foundations of MOL's future. The program was inherently and immensely expensive. Manned spaceflight demanded elaborate life support systems, intensive crew training, complex mission control infrastructure, and sophisticated operational protocols, all contributing to substantial financial outlays. The estimated cost had escalated considerably since its inception, facing increasing scrutiny from budget planners. Simultaneously, rapid advancements in unmanned satellite technology began to offer highly competitive alternatives. The United States' highly classified Corona, Gambit, and Hexagon reconnaissance satellite programs were achieving remarkable success, delivering high-resolution imagery and electronic intelligence with increasing efficiency and reliability. These automated systems did not necessitate human presence in orbit, thereby eliminating the immense costs, logistical complexities, and inherent risks associated with manned missions. Furthermore, they could be deployed in greater numbers, operate autonomously for extended durations, and often with significantly shorter turnaround times between missions. A growing debate thus intensified within the Department of Defense and the intelligence community regarding the true cost-effectiveness and unique utility of human operators in space for reconnaissance. While MOL advocates argued for the unparalleled adaptability and real-time decision-making capabilities of humans, critics underscored the increasing sophistication of automated systems that could perform similar tasks more economically and without risk to human life. The strategic landscape was also shifting, with an increasing emphasis on détente and arms control between the superpowers, reducing some of the immediate pressures that had originally justified such an aggressive and costly manned military space platform. On June 10, 1969, Secretary of Defense Melvin Laird officially announced the cancellation of the Manned Orbiting Laboratory program. The decision was primarily driven by the burgeoning costs of manned spaceflight, the demonstrable success of unmanned reconnaissance satellites, and a reevaluation of strategic priorities. Despite the significant investment of resources and human capital, the perceived advantages of human involvement in orbital reconnaissance no longer justified the extraordinary expense and inherent risks. The cancellation had immediate consequences for the 17 astronaut pilots who had committed years to the program. 7 of these highly qualified individuals, Carol J. Bobko, Robert L. Crippen, Charles G. Fullerton, Henry W. Hartsfield Jr., Don L. Peterson, Richard H. Truly, and Albert H. S. Overmeyer, transferred directly to NASA. They subsequently formed the nucleus of future space shuttle crews, contributing significantly to America's civilian space efforts. Indeed, several went on to command space shuttle missions and hold prominent positions within NASA. The MOL program, though never achieving its operational goals, did validate numerous technologies and operational procedures relevant to future manned spaceflight, particularly in areas of long-duration orbital stay and payload integration. It remains a profound example of Cold War ambition, a testament to the pursuit of ultimate strategic advantage through human presence in space, which was ultimately overtaken by technological evolution and changing strategic imperatives. MOL stands as a significant, albeit unfulfilled, chapter in the history of military space operations.